November 17, 2017. It's an A-Day. Objective 4, what is the probability that you will get a brown-eyed child if both parents are heterozygous?
Thank you, sir. Okay. In your notebooks, you are going to answer these questions. So, question number 1 is actually a statement. It's a directive. It wants you to draw a person with the following genotype. So their genotype is big D, little d, big C, big F, and 2 little L's. So this information is given to the right of this statement, and it tells you that dimples are dominant to no dimples. Curly hair is dominant to straight hair. Freckles are dominant to no freckles. And long eyelashes are dominant to short eyelashes. So the letters correspond to what they are. If they're dominant, they're obviously uppercase, and if they're recessive, they're lowercase. Then you have 2 questions. Which of the traits are heterozygous and which ones are homozygous? So I'll give you guys about 2 minutes to draw and answer the questions. And then I'll ask for a volunteer to come up here and draw the person for us, please. Okay, so Tyler is drawing dimples. He's drawing what kind of eyelashes, Tyler?
Short.
Short eyelashes. What type of hair, Tyler?
Curly.
Okay, and what's the other trait? Freckles or no freckles?
Freckles.
Okay, so how do we know this? He has curly hair, freckles, short eyelashes, and dimples. Somebody tell me how we know it's dimples. For big D, little d, how do we know it's dimples, Austin? The D is dominant. Good job. So you have to have at least one dominant gene to show that trait. So we got dimples. Hair texture is curly. How do we know it's curly, Trev? Good. There's 2 dominants. Rivette, how do we know that the person had freckles? Yeah, big F is dominant. Good job. How do we know they have short eyelashes, Liz? Right. And in order to show the recessive trait, Mr. Webb, how many genes do you need that are recessive? 2. Thank you. So, which traits are heterozygous? Want me to sing the song to Miss Joni? I'm different. Yes, I'm different. Pull up to the scene with my different genes. One's dominant, one's recessive. Heterozygous, because I'm different. We are family. Homozygous are we? Because we're the same. The genes are the same in homozygous. The genes are different in heterozygous. Somebody tell me which traits are heterozygous. Give me one trait that's heterozygous. Dwayne. Dimples is heterozygous. Why, Kaylee? Excellent. We got different genes. Good, good, good. Naomi, give me another one that's heterozygous. Freckles, tell me why, Naomi. Excelente. Which traits are homozygous? Chels. Curly hair, good. It's homozygous what? Alec, are you with me or are you talking to Webb? Oh, good. Homozygous what is this, Alec? Curly hair, but is this dominant or recessive? Dominant. So when you identify this, you have to say dominant or recessive. Why? Why can't I just say homozygous? Because they're the same. But I need to say homozygous dominant. Why? Yes, you do. This is homozygous dominant. Why? They're both capital, but it could be homozygous what? Recessive. There's only one way to represent heterozygous. There's only one way to represent 2 different genes. Homozygous can be dominant or recessive depending upon whether the letters are capital or lowercase. So this is homozygous dominant. Somebody raise your hand and tell me which one is homozygous recessive. Go ahead, Trev. LL for eyelashes. And this is homozygous recessive. Why is this homozygous recessive, Kay? Kaylin, why is this homozygous recessive? Yeah, Miss Davis, let's go. Why is this homozygous recessive? Yes, you do. Let's go. What is homo? What does that root mean? Same or different? Same. So are these the same or different? They're the same. And look up here. Dominant would be what letter? Uppercase L. Recessive would be what letter? Lowercase l. So what are these? Dominant or recessive? They are recessive. Are they the same or different? The same. So they're homozygous recessive. Good job. All right. You have an activity to do. One moment, please. Well, the capital always goes in front. These two are the same, even though the male gametes are different, but the female gametes are also different. This has one set of gametes that are dominant, one set of gametes that are recessive. So when you cross genes, you're always going to have one dominant, one recessive. It doesn't matter who gave it to you, your mom or your dad. In this case, both of the gametes are not homozygous. They're what? Both of the gametes, they're not homozygous. They're what, Amanda? If they're different, they're heterozygous. Good. Somebody tell me what goes in this first box. What goes here? Dwayne. Capital S, capital S. Good. Yesenia, what goes here? Excellent. Caitlin, what goes here? Capital S. And then what goes across? Little s. And the last box, Jels, what goes here? Two small s's. Good. What percentage are going to be smooth? What percentage are smooth? Look at the board. Johanny, what percentage are smooth? Yeah, I'm making up my own questions. What percentage are smooth? All right, let's look at this. Smooth or wrinkled? Smooth. Smooth or wrinkled? Smooth. Smooth or wrinkled? Smooth. What is this one, Ty? Wrinkled. So, how many of them are smooth? 3 out of a possible 4. So, what percentage overall is smooth? 75% is smooth. What percentage is wrinkled? Are wrinkled? 25%. What fraction are wrinkled? What fraction are wrinkled, Naomi? How many are wrinkled? 1 out of a possible how many? 4. So the fraction is 1/4. Good? When we use Punnett squares and there's only 2 gametes, there's only 4 possibilities. So it's always 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4, or 25%, 50%, or 100%. It could be 0% as well. All right. I want you to take out your yellow notes because I want to go over the yellow notes quickly because it's only one little tiny page. This is going to be how you're going to study for your test. Your test is going to be on December 1st is a Friday. The 2nd and the 3rd is Saturday, Sunday. December 4th, we're going to go upstairs to the library and do a presentation from Brookhaven Lab. So you're going to be missing, what is it, second period? You're going to be missing first period, I think. Or third, I don't remember. I have to look it up. It might be first or third. And then the 5th is going to be your test the following day. This page. Page 4. Okay. Go to page 4, please, in your notes. All right. You used a square called a Punnett square. A Punnett square is made with 4 boxes. This is also a type of diagram. So we're going to call this diagram, yellow notes, please, a chart. So a Punnett square is a chart. And this chart is going to show all the possible outcomes of your offspring. Does that mean my offspring are definitely going to be like this? No, it's probability. Flip a coin. You always have a 50% chance, but you could always flip ahead 5 times. I have 4 children. They all have blue eyes. The probability of them having blue eyes was only 50%. And they all got blue eyes, 100% of them. Blue-green. I should have had 2 blue and 2 brown because I have 4 children. But does it mean the next time I have a baby it's going to be brown eye or blue eye? Do I know? No, I have no idea. It's a 50-50 chance every single time. No more babies. All right. You're going to use the Punnett square to predict the traits. You can do this for any trait that only has 2 alleles. Every trait. Yesterday's mother, do you remember what she looked like? What color eyes did she have? Blue eyes. So the mother's genes had to be what? If she had blue eyes, what was her genotype? Mr. Webb. Good. She had 2 little b's. Her phenotype is her, what did we say phenotype meant? Phenotype is a word that describes your physical features. So if her genes were her genes were 2 little b's, what's her phenotype, Webb? Blue eyes. Good job. Dad had what color eyes, Chels? Brown eyes. So Dad's phenotype was what, Tyler? No, phenotype. You just said it. Brown. Dad's phenotype is brown eyes. So, Dad, we don't know what Dad's genotype is, do we? We don't know, but we're going to make an inference that he's heterozygous. So if Dad's heterozygous, Kaylee, what is Dad's genes? Heterozygous. Good. He could have been big B, but we don't know. But we are going to say he's big B, little b. So when you're using the Punnett square, you're always putting the parents' genes, their gametes, on the outside of the Punnett square. So your Punnett square in your notes packet, please put Dad's gametes on the top. So if Dad's goes on the top, what goes on the side? The mom's gametes. Are you ready? Can you scroll that down, baby? So we can get here. Okay. Mom's on the side, Dad's on the top. Somebody come up here and move the gametes to the first box for me, please. Go ahead, Rivette. Yeah, what goes in? They're infinitely cloned, so you can move them. Okay, so when he's moving, uppercase B and lowercase b. Good job. Somebody give me the next box. Go ahead, Webb. You can do the next one. Lowercase and uppercase. Does it matter what order we put them in? No, but yes. Because he could have put any one of these in the different order because they're both the same size. But when we write this, what has to go first? The big one, the uppercase. Go ahead, Tyler, do the next one. And then Sanaya, do the next one. I'll help you. Come on. Yes, you do. Oh, you thought you said you didn't know how. Okay, now we got one from the, wait 1 second. One from the top, now get me one from the side. There you go. Perfect. Go ahead, Sanaya, do the next one. Good, so it doesn't really matter which one goes first in this case because they're both small. All right, we're filling in the possible combinations, and we notice that each box represents what percent? 25%. Somebody tell me the fraction that it represents. What fraction does it represent, Tyler? 1/4. Good job. The percent chance that the child will be born with brown eyes, Darian? What percent will have brown eyes? Well, let's look. What color are these eyes? Well, this has one dominant and one recessive. What color? Brown eyes. Why does it have brown eyes? Explain it to him, Tyler. Brown is dominant. How many dominant genes do you need? Just one. Austin, what color are these eyes? Blue. Why is this blue, Sean? Right. So this is going to be blue, and that's going to be brown as well. Let's answer these questions before the bell rings. What's the percent chance a child will be born with brown eyes? Tyler. 50%. Good. How about blue eyes? 50%. Excellent job. Today's question is, what is the probability that you would get a brown-eyed child if both parents were heterozygous? We'll answer it on Monday.